So for correlation and regression analysis, we are given data, which is ABC company, and the data is attached. And so we are supposed to answer the following questions. We have to create and show the correlation matrix for the relationships. And then after we have created the matrix, we need to show which variables significantly impact the employee's salary and explain why. And then we have to show which variables are not significantly impacting employees' salaries. And also we have to explain why. And we have to use a scatter plot to present the relationship between salaries and gender. And then we have to explain our visualization. And then we have to use simple linear regression analysis to find out if the number of years employed significantly determines the salary levels of these employees. And then we have to provide conclusions and recommendations. And finally, we have to use simple linear regression analysis to show the relationship between salary and all dependent variables. And then we have to explain which are significant and which are not. So we're going to open data. We have employee salary, years of previous experience, years employed, and so forth. We know that salary is dependent variable that depends on these independent variables, meaning years of previous experience, years employed, years of education, gender, department, and number supervised. In fact, we can write it like this. So we can say salary is a function of, we can call this x1, x1, x2, x3, x4, x5, and x6. So salary, we can also call it y. So we can say y is a function of x1, x2, x3, x4, x5, and x6. We have to create the correlation matrix, and in order to do so, we need to use data analysis. Now, I am using Mac, and all I have to do is I can go to the tools and then click on Excel add-ins, and then I will select analysis toolpath, and then I can click OK. So if I click on the data, then I can see analysis toolpath or analysis tools is here, and so I can use it. Now it's a little different from with Windows. And so with Windows, you can go to the file, and then you can go all the way down. You will find options. And then when you click on the options, you will get another table where you should find add-ins. And then you'll get another table where instead of clicking OK, you will click Go. And then you will find another table where you can check the box for analysis toolpath, and then you can click OK. And so if you click on the data analysis, then you will get this table where you can select correlation. So I will select correlation and then click OK. So Excel will ask you to provide the input range. And in this case, our input range will be all the values starting from salary to number supervised. So I will select all this. So you can see that I have selected um, all these variables and their observations. And I would like to group this by columns instead of rows. And then labels in the first row, we have to select the labels as well because we have included them. And then we need to select the output range. We can use the new worksheet or new workbook, but it is good to use the output range where you can show where you want your results to be. So click on this box and then select any place where you want your data or your output to be. So I'm going to select here close to the data, and I think I'm all set. Then I'm going to click OK, and you can see that we have correlation matrix. And in this case, we will select the first two rows for now, where we have salary with all these factors or variables. So we want to consider the first one where we have salary and salary because they have perfect correlation. That's one. But we are looking for salary and years of previous experience, salary and years employed, salary and years of education. Same with gender, department, and number supervised. So the question which was asked was, first of all, to create the correlation matrix, which we have done. And second, it says which variables significantly impact the employee's salary and explain why. So if we can go back to this, we can look for the variables, meaning that these variables, to see which one has significant correlation. Normally, correlation we know is the value between 0 and -1 and also +1. And let me put 0 here. So starting from 0.5 negative, let's see, negative 0.5, and here 0.5. So any values less than negative 0.5 towards 0 or less than 0.5 positive towards 0, we can say that those values are actually not significant. However, if you have any values starting from negative 0.5 towards -1, we can say that we have significant negative correlation between the variables. And also, if we have correlation starting from 0.5 towards +1, we can say that that correlation is significant, and it is a positive significant correlation between the variables. So this is actually the simple way of understanding how correlation is strong or weak, and therefore we can use the same understanding here. And you can see years of previous experience has no significant correlation. There is a correlation which is 0.03, but this is less than 0.5. Actually, it is almost close to 0 because it is 0.03, and actually it's positive. And so we can say that the correlation between salary and years of previous experience is not significant. So this variable, in our case, does not affect salary significantly. So let's look at the years employed. we can see that correlation is 0.76 or 77, and it is above 0.5, and it's actually towards +1. And so we can say that there is a significant correlation between salary and years employed. So this variable significantly affects salary. Years of education as well, we have 0.78, and that is way beyond 0.5. It is almost close to 1. And so we can say that the correlation is significant. Therefore, years of education significantly affects the salary. Now let's look at the gender, where we have minus 0.25, and it is less than minus 0.5, and it's close to 0. So we can say that gender and salary have weak correlation, and in that case, gender do not affect salary significantly. Department in this case is 0.37, and so we could see that this variable is less, the significance between salary and the department is less than 0.5, but it is almost close to 0.5, and therefore we may need to test this correlation to see if it's significant or not. But we could also say that since it is less than 0.5, therefore this correlation may not be significant. So I'll use the language that may not be significant unless we go further and test it. Now, number supervised is 0.5, and this is actually more than 0.5, and therefore this correlation is significant. And therefore, number supervised has an effect on the salary. So variables that do not affect salary significantly are years of previous experience, gender, and probably department. All other variables have significant effect to salary. So in this case, we have answered which variables significantly impact the employee's salary and which one do not impact the employee's salary. So the fourth section says we have to use the scatter plot to present the relationship between salaries and gender. So all we need to do here is to create the scatter plot between salary and gender. So I will select this column and then hold down Command key and then click on the gender, because we want to create the scatter plot for these two variables, salary and gender. And so we need to select only these two, and then we can go to insert, click on the insert, and then go to the recommended charts. In fact, you could use the scatter plot, but you can first start with the recommended charts. And in this case, we have this scatter plot, and so we can click on this, and that is the scatter plot that we can create from between the salary and gender. So in fact, in this case, you can see that we don't have any correlation because for us to have a correlation, we can have either negative linear correlation or positive linear correlation. But in this case, we can see that our scatter looks different, and therefore we can say that there is no, the scatter plot shows no correlation between gender and salary. Then we can go to the the fifth question, which says use simple linear regression analysis to find out if the number of years employed significantly determines the salary level, and provide conclusion and recommendations. And also we will need to use the simple linear regression analysis between salary and all other dependent variables. So this is actually not simple but multiple linear regression because it involves salary and all dependent variables. So we're going to start with problem 5 or question number 5, which says use simple linear regression analysis to find out if the number of years employed significantly determines the salary levels of these employees, and we need to provide conclusions and recommendations. So this is simple linear regression because it uses two variables, which are years employed and salary. So if you can go back to Excel, now we have salary and years employed. So I'm going to data analysis. If you don't find it, just click on the data, and then you have data analysis. And in this case, we are going to select regression, not correlation. So we have regression and click OK. Now, all we want to do here is to select the Y range and X range. So we're going to start with Y range. And Y range is the dependent variable, which is salary. And therefore, I'm going to select from the label all the way down to the last value. And then I will also select the X range. And in this case, we have years employed. I'll start from the labels as well. And then I'm going to select all the way down. And then I have to check the labels because we have included the labels, and so check the labels. And then we need to decide on the output range. And the output range, you can select anywhere where you want your results to be. For me, I want my results to be here. So I'll click in here and select this cell. You can go to any cell of your choice. I will include also residues. I think I'm done, and so I can click OK. So you can see we have results, or I will say simple linear regression results. And so we have multiple R, which is correlation. And this correlation looks exactly the same as the correlation which we had when we created the matrix, and that is 0.77. And so that's what we have here, and that is significant correlation. And then we have R squared, and so this is the coefficient of determination, which shows how much the independent variable or independent variables could explain the dependent variable. And in this case, we can see that years employed could explain salary by 59%. And so we have 41%, which is unexplained. But this is okay. And in this one will be determined by the p-value. So we can look at the years employed here, and in the p-value we can see it is 0. We have 0.10 zeros, and then you have 5, 9. because here we have exponential value, which shows that we'll have 10 zeros, then you can come to 593, and this is almost 0, which is the good p-value. So make sure that the p-value is of interest for you, because if the p-value is greater than 0.5, then we can say that years employed is not significant, does not significantly impact salary. But because the p-value is less than 0.05, and so if it's less than, then we can say the years employed is significant. So as I said, correlation is okay. The R squared is also okay. It's above 50%. And then we can see the p-value of the years employed is also 0, showing that years employed is significant. And in fact, this proves the correlation. Now, with regression analysis, we have coefficients, and here we have intercept, which is y-intercept, and here we have slope of years employed. Now, we can see that if years employed is significant to salary, then we can say that a year of employed or additional year employed will increase salary by this much, and this amount is significant. So that's all with the simple linear regression. Now, the other section requires us to use not simple but multiple linear regression analysis to show the relationship between salary and all the other dependent variables. And so all we can do is to go back to the data analysis and select regression and click OK. At this time, our dependent variable will still be salary, and so it is the same amount, but X range will be all these other variables. So I will select all of them, excluding salary, which is dependent. And so this will be our X range, and everything remains the same except the output range. And I will need my output to be, let me select somewhere else. So I'll put the output range below the first outcome. And so remember to check this box and click where you want your output to be. And then you can click OK. So in this case, you can see that we have results. We have multiple R, meaning that the correlation of the dependent variable with independent variables, and it is 0.9, which is significant. That's okay. The R squared shows that the independent variables could explain the dependent variable, which is salary, by 82%, which is very good. And the adjusted R squared, adjusting this R squared, is 0.79, which is still okay. So we should come down here again, and we need to focus on the p-value. Remember, the p-value should be less or equal to 0.05 for any variable to be significant. If the p-value is greater than 0.05, then the variable will not be significant. Now, in that case, let's look at the years of previous experience. We can see that years of previous experience is not significant, and therefore years of previous experience does not have any effect on salary because the p-value is greater than 0.05. But years employed, you can see that we have this exponential value, meaning that we have 0.5 zeros, 1457. It is almost equals to 0. Here also we have exponential value, which gives us 0.5006000767, and therefore this also is almost 0. And the years employed and years of education have significant impact on the salary. Gender has a value which is greater than 0.05 or the 5%, and therefore gender is not significant. Let's look at the department. Department has 0.001, and this is different from what we got from the correlation. In this case, we can see that the p-value is less than 0.05. So we can say that department now is actually significant, although correlation between department and salary was less than 0.5. It was 0.3 something. This one 0.34. And remember, before I said maybe not significant, and now we have proven that it is actually significant when we use regression analysis. So department in this case has a value which is 0.001, and this value is less than 0.05, and therefore it is significant. Let's look at the number supervised. So for the number supervised is actually the opposite. Now it shows that this is not significant because the value is greater than 0.05. It is 0.14. So number supervised is not significant when we combine all the variables together, when we use multiple regression analysis. But when we look at the correlation, number supervised, we can see that this value was significant.